Hi, fifth graders. So we need our journal and our pencil, and today we start our journey of multiplying fractions and whole numbers. So on page 45, look at us, we're getting close to the bottom. Whoop, whoop. Okay, we're going to write multiply fractions, and this is going to be with models. We're going to spend 2 days with models and multiplying fractions. Models are everybody's favorite, aren't they? But don't worry, we get to check our models with the algorithm. And by the time we get to Friday and we get to multiply fractions with only the algorithm, you're going to be professionals. So when we open our notebook and we get to page 45, you write 45. This is going to be multiply fractions and whole number models. And I use the, I guess what y'all would call hashtag, but this is also the number symbol in math. So multiply fractions and whole numbers. And I'm going to get this a little closer. I didn't realize how far that was. And that should be a little bit better. So give me a second. Okay. Oops. There we go. Okay, so today I'm going to show you how to represent multiplying fractions and whole numbers using repeated addition. So the first way that you can represent fractions and whole numbers, multiplying them, is with models that represent repeated addition. Okay, so we're going to put underneath here repeated addition. Multiplication is simply repeated addition. You take the same amount and you multiply it however many times it tells you to. So the first one that we're going to be working on today is 3 times, this is going to be example 1 today of 3. 3 times 3/8. And what I want you to think of, what I want you to start thinking about when you're doing this multiplication is I want you to think of it this way. 3 times 3/8 is the same thing as thinking of it as 3 groups of 3/8. So if we wanted to draw a model that represented 3 times 3/8 or 3 groups of 3/8, how do you think we could start drawing that model? 3 groups of 3/8. 3 times 3/8, because that's what we're actually doing here. We're figuring out how many sets of 3/8 there are. How could we make that look? Well, I sure hope you thought, well, Miss Jones, we could draw one example of 3/8. I'm going to cut it this way. And that way, did I get 1, 2, 3, 4, 5, 6, 7, 8? So there's 8 parts. If I wanted to represent 3 groups of 3/8, to represent 3 times 3/8, I would draw 1 groups of 3/8. And I would shade 3 of those 8. I would draw 1 circle in 8 parts and shade 3 of the 8s. So how many groups or sets of 3/8 do we have modeled so far? That's right, we only have 1. How many do we need for 3 times 3/8? We need 3. So guess what? We're going to draw another one in this model. One, 2, 3, 4, 5, 6, 7, 8. Of course, they'd all be even and equal if I had the ability to make them perfect. All right, so how many sets or groups of 3/8 do we have so far? We only have 2. Our problem says we need to figure out how much we have if we have 3 groups of 3/8 or 3 times 3/8. So let's draw another one. Now 1, 2, 3, 4, 5, 6, 7, 8. Okay. So that would be 3/8 and 3/8, 3/8. So really our answer is just adding those 3/8 together. 3 plus 3 is 6, and 6 plus 3 is 9. We would get 9 out of 8. But this is improper, so this is not how we would leave it. We would not leave it this way. We would think, how many times can 8 go into 9? Because we can't leave this fraction improper, so we fix it by dividing 8 into 9. 8 can go into 9 one time. 8 times 1 is 8. We subtract. We have 1 left over. Now all you have to do is write your fraction as a remainder. So I have 1 left over out of the 8 original pieces, so it becomes 1 1/8. Okay. So we just modeled what 3 times 3/8 looks like. 3 groups of 3/8 is going to look like this. It's going to give us 9/8, which totals 1 1/8. But let's see what this looks like using the algorithm. Okay. So the algorithm here, going back to my 3 times 3/8, would look like this. You take this whole number, okay, and before you can multiply a whole number times a fraction, rule number 1 is that you have to turn this whole number into a fraction. And you do that by writing 3 over 1. Now, I chose the denominator of 1 because I wanted to create a fraction that still has the value of 3. And a way that you do that, I'm still multiplying 3/8 times 3 when I do this, because 3 over 1 is equivalent to 3 wholes. So I'm able to take this number 3 and turn it to a fraction and still have it be the same value. And then we can keep our sign. We write 3/8, and now all we have to do is 3 times 3, and that's 9, and 1 times 8 is 8. And you see how this here gets us the same thing here. Isn't that cool? Which is also the same thing as these 3 models together. And 9/8, again, can't be left as 9/8, so we change it to that mixed number we found earlier of 1 1/8. Okay? Okay. I think we're only going to do 2 examples in our book, and then we'll do 2 more from your assignment today. That way we use our time wisely. Okay, so we'll do 1 more example together. So I want you to think of today's assignment as repeated addition. So when you're drawing your models for it, you're representing that fraction in that number of groups. So for example, if we had 2/3 times 6, okay? So what we're thinking about is how many 2/3 groups are there in 6, or how many 2/3 sets of 6? So I'm trying to figure out how much we have if we have, 6 sets of 2/3. So let's start and let's model what it looks like to have, 6 sets of 2/3 or 6 groups of 2/3. Okay. I guess we could say 2/3 of 6 groups. Okay. So we got 2/3. So let's draw something to represent 2/3. And I'm going to just use a rectangle because I think that'll be easier to separate in 3 parts. So this says we need to see how much we have if we have 6 groups or 6 sets of 2/3. So I'm going to shade that. And how many sets of 2/3 do I have modeled so far? That's right, I only have 1. So I've got to keep going. So now I'm going to work on another set of 2/3 because this problem says you need to have 2/3 represented 6 times. So I'm going to shade this, and I'm going to shade that there, and I have 2/3. I got to keep going though. I only have 2 sets of 2/3, all right? I'm trying to figure out 2/3 of 6, all right? 2/3 of 6 groups. I need to have 6 sets here. So I'm going to keep going. And how many do I have now? 3. I'm going to keep going. I'm going to move a little faster here. They're kind of getting sloppier, not very even, are they? Oh well. So that gives me 2/3. 1, 2, 3, 4. I gotta keep going. And that's gonna give me 1. Okay. 1, 2, 3, 4, 5. One more. One more. So I have 6 groups of 2/3, or 6 2/3 sets. There we go. I have 2/3 represented 6 times. 2/3 represented 6 times. All right, 2/3, 2/3, 2/3, 2/3, 2/3, 2/3. So my answer here is to add all of these together, okay? 2 plus 2 is 4, plus 2 more is 6, 2 more is 8, 10, and I get 12. So our answer here is 12 over 3. But of course, I'm not going to leave it 12 over 3 because that would be improper. So really, all I have to do is think, how many times can 3 go into 12? That's right, 4 times. So that means 2/3 times 6 is equal to 4. And so let's try that algorithm out and see if we get the same thing. Remember, we're just, all we're doing when we're multiplying a whole number times a fraction is repeated addition. So my algorithm is going to look like this. I'm going to write 2/3 times. I have to change my whole number to a fraction. And I want to keep my fraction to have the same value. So I do that by writing 6 over 1. 1 can go into 6. We're going to fix this improper fraction 6 times. So you can see that writing 6 over 1 is the same thing as 6. That's why we can do that. And that's why we put the denominator of 1, because we don't want to change the value. We still want to be multiplying 2/3 times 6. So now once I have my whole number written as a fraction, I can multiply across the numerators. 2 times 6 is 12. And I multiply across the denominators. 3 times 1 is 3. The last thing we have to do is fix and simplify. We cannot leave our fractions improper. You'll have, every problem you do today is going to be an improper fraction. So that means the last step is that you have to divide that numerator into the denominator. 3 can go into 12 4 times. So there you go. Either way, with the models, adding them, or using the algorithm, we get 4. All right, so let's get started on your practice today. So this is your assignment. It's all online today, but I wanted to help you set up how to do your paper and what I want you doing for your practice. In your directions, it says, please send me a picture or a video message in my inbox of this work for proof that you are doing these assignments, practicing the skills I've asked you to do. So for question number 1, I know, a big one off the bat, right? 7 times 2/3. Or another way to think about that is 7 groups of 2/3. Okay, so we want to draw a model here. We're practicing models today, checking it with the algorithm. That's your assignment. So let's start with our model. 7 groups of 2/3. So we're going to go back. We just did 2/3 pieces, so now we're going to have one more extra. So we're going to start drawing them and shading them. There's one set of 2/3, 2, 1, 2. I guess I don't need to write 2/3 every time. 1, 2, 3, 4. 1, 2, 3, 4. How many more do I need? 3. That's right. 1, 2, 3, 4, 5. 6, 7. Okay. So let's check this out with the algorithm. It's faster. We could add 2/3 plus 2/3 plus 2/3 plus 2/3 plus 2/3 7 times. Let me 7 times 2 be 14. 14 over 3 is what we should get. All right, so let's go through the algorithm again. Before we can multiply in the multiplication algorithm, a whole number has to become a fraction. We make it a fraction by giving it a denominator of 1, so we do not change its value. We multiply it times 2/3. Once you have 2 fractions you can multiply, all you have to do is multiply across the numerators. 7 times 2 is 14. multiply across the denominator. 1 times 3 is 3. You will have improper fractions all day today. You cannot leave them improper. It will be counted wrong. You must divide the numerator into the denominator. 3 can go into 14. 3 can go into 14. Let's see, 3 times 4 is 12. 12. So 4 times 14 minus 2 will give us 2. And now we just have to write our remainder as a fraction. That'll be 2 out of 3. 2 out of 3 left over. And 2/3 is already in simplest form because I have 2 prime numbers. So thank goodness. There might be a few today that you have to also simplify the fraction once you get after you convert the improper fraction. I know. Not nice, huh? But you can do it. You know how to simplify fractions. You know how to convert improper fractions, and you know how to simplify. All right, so that is your answer to number 1. When you type this in today, please be sure that you write the 4 and then do a space on the board, on your keyboard, and then do the 2, and it looks like the backslash. It's this key right here. So when you go put this in to the computer, you're going to hit 4, and then you'll hit the